Dr. Powell. Let's take a look at how we can take a set. So we're going to take the set A right here and define an operation on it such that that operation induces an operation between chunks of A. Okay, so this table right here defines an operation on A. First of all, how? Let's see. If we take 3 and then we do star, so 3 star 4, this tells us 3 star 4 is 2. Okay, so we have a nice operation defined, okay, on the set A between the elements of A. You apply this operation between two elements and you get another element of A out. All right, now notice the chunks that we've made. This one, 1 bar, 3 bar, 5 bar. What in the world does that notation mean? This simply means the chunk. So we've chunked A up into pieces. Okay, there's a piece, there's another piece, there's another piece. It just means the piece that 3 lives in. So we could have alternatively wrote 4 bar, the piece that 4 lives in. Notice the piece that 3 lives in, the piece that 4 lives in is the same, so we could have used 4 bar instead as a name, but we just chose a representative element of each chunk and then just named it in such a way. So we have one. So here we can name them, and notice that 1 and 2, that's 1 bar. This is 3 bar. That's 5 bar. 5, 6, 7, and we can go like this: 1 bar, 3 bar, and 5 bar. You notice anything here? If I add anything in 3 bar to anything in 5 bar, what do I get? Wait, these are the elements of only one of the chunks. Ah, okay. Now, if in contrast I happen to have a 1 in here, that would be messed up, and this would not be just one chunk. But since the outputs, the addition outputs, like 3 plus 7 is in, 3 bar, 3 plus 6 is in 3 bar, 3 plus 5 is in 3 bar, 4 plus 5 is in 3 bar, all of them are in the exact same bar, then this works. We can make a table like this to actually denote an operation between the chunks. Notice that this guy's all of these are in 1 bar. All of these are in 5 bar. So we can denote the bar right here in this table where it is, and we have a well-defined operation right there between the chunks. If when we make a table like this and we draw lines here after we've ordered things by what chunk they're in, the rectangles that we see, if each rectangle describes just one and only one chunk, or at least all the elements are in that chunk, like right here. I don't have the whole chunk, but at least I know that I'm not going outside of a chunk. I'm always within a chunk. Then we know we have a well-defined operation between the chunks. Now we can represent this via a diagram of functions. All right. Now, so what we're going to be looking at here is this is a merge function, a to a over bar. So the bar we're actually using a red bar. And what does that mean? What in the world is this, and what do I mean by merge function? So this is the collection of the chunks. Okay, so I've kind of divided A up and split it up into chunks that are given by this bar notation. So this is like the actual set of 1 bar, was it 3 bar and 5 bar? So we're taking a look at this collection of chunks. All right, so we have a function here from A to this, which simply means just put something inside of its chunk, like 2 would go to 1 bar, right? It's just going to its chunk. And then what is this? These are ordered pairs of A, which is kind of so, like, for instance, if I took like 1 and 4, and then I mapped it over to its respective what what bars they live in as an ordered pair. It's a Cartesian product, Cartesian product. So I have 1 bar and 4 bar, but actually, if you remember on the previous slide, 4 bar was the same as 3 bar. So I could just write down, right there, I could write 3 bar. Oh, excuse me, and let's see, just 3 bar. All right, so the idea is if we take 2 chunks, like 1 bar and 3 bar as an ordered pair, and we look at their pre-image over here, okay, so everything that would possibly map to 1 bar and 3 bar, so everything that would map to them, hey, that's kind of like any combination in this table here. Let's see, 1 bar and 3 bar, that would be like anything in like 1, 2 paired with 3, 4. So anything in 1, 2 and anything in 3, 4 kind of paired together. There's 4 options for those pairings, and that actually represents what that pre-image is. Over here, there's 4 ordered pairs in this pre-image. So all of these guys, all right, as a set, are going to map down to A. How? Via this operation among the elements of A. So like 1 star 4, for instance, where is that going to map? All right. So I mean, what is that? That's where 1, 4 is mapping. So 1, 4 is going to map down to whatever 1 star 4 is, and we can see what that is in our operation table. So 1, 4, that's 5. Okay, so that's 5. So 1 star 4 actually, so that's 5. So 1, 4 maps down to 5. And then the question is, which bar does 5 map to? Well, it maps to 5 bar. Okay, so actually, what we have is 1, 3. We have a way of saying what 1, 3 goes to when we star it. So here, so this is going to be like the starring operation for 1 and 3. So 1 bar star 3 bar should be 5 bar. Now, if we look at it this way, we need to make sure that we only get one thing. Not lots of things, but just one thing. Well, remember what's in here in the pre-image of this guy. So this guy is actually sent back to like 4 different ordered pairs. And all those ordered pairs have to, they're going to, in the addition table, they're going to map to some things. And those things are going to be represented in the rectangle. So the rectangle, okay, so right here we have, so 4 bar is really okay, so it's 3 bar. So it's really anything in here crossed with here, and we're looking at all the outputs. See all these outputs? 6, 5, 7, 7. That is actually what is sitting right here. Okay, so right here is what those outputs are. And then we want to know simply, are those outputs, when we chunk it, are those outputs in the exact same chunk? And if they are, we have a well-defined operation. So really, this is just kind of like a diagram way of saying what we said on the other slide, is simply that you just need, when you add two things, if you take a representative element of here and a representative element of here, back here, you always should be getting the exact same thing down here, and let's just define that to be the result of our operation. And so we have just discussed how to define or what kind of has to go into an operation on the set A so that we actually get an operation on the chunks. Thanks for watching.